there. My name is Dr. Marissa May. In this video, we're going to be looking at operations with polynomials. Now, I thought, first of all, we might need to talk about what is a polynomial. So you can see in the green here, I have a few examples of a polynomial. And here in the red, I have an example of something that is not a polynomial. So what do you notice that's different? I'm seeing some exponents over here with the polynomials. I'm seeing them being added and subtracted. I see a subtraction over here, but did you notice that the variable is in the denominator? So having the variable in the denominator means that we're not dealing with a polynomial. So what I'd like to do in this video is I want to look at how do we add polynomials? How do we subtract polynomials? How do we multiply them? So let's take a look. I'm going to look first at addition, and then we'll do a subtraction. So when we have polynomials and they're being added together, we want to look for something called like terms. So like terms have the same variables and the same exponents. So if I look for a like term to go with a to the second, I need to look for another term that has an a to the second in it. So you can see that here. So 1a to the second plus another a to the second will give me 2a to the seconds. Now, let's add the ones that have a's with them. So here I have a 2a, and notice I'm not combining these with the a to the seconds. In fact, I'm going to go ahead and mark those a to the seconds out just so it'll be easier for me to keep track. So I have a 2a, and I'm going to combine that with a negative 2a. So 2 apples take away 8 apples will give me negative 6 apples, right? So 2 plus negative 8 would give me negative 6. So I get negative 6a. All right. Next, let's add the numbers that don't have any variables with them. So we're going to add the 3 and the 5, and that gives me 8. And so this would be my final answer here because I have combined everything that had the same variable and the same exponent. So this is my final answer here. Okay, let's do the subtraction. And I want you to see subtraction is very similar to addition, but it has one extra step. And that step is dealing with that subtraction. So first thing that I want you to do is we're going to change that subtraction to an addition. You may be thinking, oh, Dr. May, why are you doing that? Well, because I'm going to change that to an addition. But if I do that, I have to change all of the signs in this second parentheses. So this 3x to the second is going to become negative 3x to the second. This 8x is going to become negative 8x. This 4, positive 4, is going to become negative 4. I circle them only because I want them to stand out in my mind. Oh, yeah, I changed that. Okay. Now, let's do the same thing we did with the addition. We're going to combine the like terms. So let's start with the terms that have the x to the seconds to them. I've got a 5x to the second, and now I have a negative 3x to the second. So 5x to the second plus a negative 3x to the second gives me positive 2x to the seconds. Just a side note, notice I'm not changing the exponent at all. I'm leaving it alone. I'm only adding the numbers in front. Okay, just like before. I'll go ahead and cross those out so it'll help us keep track. Okay, then I'm going to deal with the x's. So I have a negative 8x, and I don't have anything to combine that with. So I'm going to leave it just like that. And I'll mark it off. Now let's combine this negative 4 together with this negative 4. And if we add those together, we'll get negative 8. And so this is my final answer here because I've combined all of the like terms that I could. Now, just like we said, subtraction is a lot like addition. The only difference is we had to change that subtraction to an addition and change the sign of the terms in the second parentheses. All right, so it's addition, subtraction. Let's look at multiplication. I've got 3 different kinds of multiplication we want to look at. So when we multiply polynomials, we have to first understand how multiplying monomials work first. So I want to think about this 5a to the 5th because I want you to picture it, how would the multiplication actually works. So 5a to the 5th, here's what that really means. That means a 5 times, now a to the 5th means a multiplied by itself 5 times. Okay. Then look at the 6a to the 6th. What that means is 6 times a times itself 6 times. Now, the reason I wrote that out because I want you to see all this multiplication that's happening. So if I do the 5 times the 6, that'll give me 30. But then look at the a's. How many a's am I multiplying? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's a times itself 11 times. So I put the 11 as the exponent. Now you may look at that and go, oh, I could have done that by just adding the exponents. You're right, you could have. But when I show it like this, written out, students understand why that shortcut of just adding the exponents works. Okay, so this is my answer here for this one. Okay, now let's look at this one. Similar, a little bit different. Let's think about what 3a to the second b to the third power means. Well, the third power here means to multiply by itself 3 times. What do we multiply by itself 3 times? The parentheses. So, draw us a little line here. That means we're going to multiply this parentheses by itself 3 times. By itself 3 times. Okay? Now, if you want to think of it like this, think about what that means. That means 3 times a times itself twice times b. And this one means the same thing. 3 times a times itself twice times the b. And this one means the same thing, times a times b. Okay, now you have the multiplication all written out. Let's multiply. 3 times 3 is 9, times 3 again is 27. Look at your a's. You got 1, 2, 3, 4, 5, 6 of the a's being multiplied together gives you a to the 6th. And then you have 3 b's being multiplied together. Now, there are some shortcuts to those rules. But I find if students can write it out, you can see the multiplication a little bit easier, and it makes the connection to the answer here a little bit more straightforward. All right, I've got 2 more types to look at. The next type has a term on the outside. We call that a monomial. And then it has a parentheses, and the parentheses has a plus or a minus. In this one, we use the distributive property. So we do the distributive property by distributing the term on the outside, the 2b to the third. We're going to distribute it to the first term, and we're going to distribute it to the second term. So when we distribute, we multiply. So we'll do 2b to the third times the 4b. And then we have the plus, and then we'll do the distributing here, the 2b to the third times the 5. Okay, let's think about what that multiplication looks like. So 2b to the third means 2 times b times itself 3 times the 4b. So 2 times 4 gives me 8. B times b times b times b, that's 4 b's. So I get b to the 4th. Okay, let's look at this multiplication. I've got 2 times b times itself 3 times the 5. So I've got 2 times 5 is 10. B times b times b gives me b to the 3rd. And so my answer, I get 8b to the 4th plus 10b to the third. Now remember, you may be thinking, well, why can't we combine that and get 18b to the seventh? Remember, they're not like terms. In order to have like terms, you've got to have the same variable, the same exponent, and you can't add them unless they're like terms. All right, we've got one more type of multiplication, and this is the one I find actually students are the most familiar with. When we have two parentheses be multiplied together, we've got a plus or a minus in one parentheses, a plus or a minus in the other parentheses. This one you may have used the FOIL technique. The FOIL stands for first outside, inside, last. I'm actually going to use a box to kind of organize that multiplication. And I'm going to put these terms from the first parentheses, I'll put them on the top. So I've got 2a and I've got positive 5. And then I'll take these two terms and put them on the side here. I've got a and negative 3. Now what I'm going to do is I'm going to multiply the 2 to fill the box. So a times 2a would give me 2a to the second. A times 5 would give me 5a. 2a times negative 3 would give me negative 6a. And negative 3 times 5 would give me negative 15. Now look at all the things that I put in the middle, filled in the box with, and I'm going to take them out. So I've got 2a to the second plus 5a plus negative 6a plus negative 15. Now, I'm going to combine like terms. So I have a 2a to the second, and I don't have anything to combine with it. But these guys I do. The 5a and the negative 6a, those are like terms. They have the same variable, the same exponent. So that gives me negative 1a, and then I've got negative 15 there on the end. So this is my final answer for this multiplication. And the box here is just a way to organize my information for the FOIL method. If you've used the FOIL method before, the box is just an organization tool. So friends, I hope this helps you with these operations with polynomials. We've got lots of details there. Feel free to go back through the video and look at the examples so that you don't miss any of those. All right, friends, have a great day.